So the dilation section from the previous lesson now leads us into the idea of similarity. So two polygons are similar if one can be obtained from the other by a dilation. A similarity transformation occurs when a figure and its image have the same shape but not necessarily the same size. So again, something's getting bigger or smaller. So the symbol for similar is the little mark that appears above the congruent symbol in terms of the equal sign. So that is your symbol for similarity. So the formal definition of similar is that if two polygons are similar, if and only if their corresponding angles are congruent. So the angles are congruent, that's part one. And then part two is that the sides are proportional. Keep in mind, the angles are equal, not the sides. The sides have to be proportional. So we're going to be setting up lots of proportions here. So you see the diagrams, everything is color-coded. You can see which angles match up with each other and they're equal to each other. But in terms of the sides, you have to set up a bunch of proportions. There's 4 sides, so there's 4 different ratios that you would have with what side matches up with which side. So we're going to start very basic here. So it says if triangle FGH is similar to triangle JKL, we're going to list all the pairs of congruent angles, and we're going to write a proportion for all of the corresponding sides. And the nice thing is we have a similarity statement to work with, so we don't need to redraw anything. So we know we have angle F, G, and H in the first triangle, and we know that they're congruent to the angles in the second one. So F is the first letter, which matches with J. So angle F and angle J. G is the second, K is the second, so they match up. And H and L match up. Now in terms of sides, we're going to do something very similar. It's a triangle, so we know we're going to have 3 different ratios for our sides. And what I'm going to do is I'm going to match up. So I'm going to take the first and the second letter, FG, and then I'm going to take the first and the second letter of the second triangle. I'm going to take the second and the third letter of each, writing in the same order, and I'm going to take the first and the third, the first and the third. So there are my 3 different corresponding side ratios that eventually will be used in a proportion. Okay? All right, let's try one for a 4-sided figure. No different in terms of the approach. I'm going to take the first figure in terms of the letters N, P, Q, and R, and I'm going to list them out. And since they're giving me already a similarity statement, I know who they match up with. So N goes with U, P goes with V, Q goes with S, and R goes with T. So there's my angles. With sides, though, it's 4 sides, which means I'm going to have 4 different ratios to work with. And I'm going to follow the same trend that I did for example 1. So I'm going to take the first and the second of each. I'm going to take the second and the third. I'm going to take the third and the fourth. And I'm going to take the first and the fourth. And I have my 4 ratios. So now where this is going to eventually lead us is we're actually going to be calculating this stuff out. So it says the ratio of the lengths of corresponding sides of 2 similar polygons, it's called the scale factor, the common value they have amongst the 2 triangles or the 2 figures. So it says in the diagram, triangle ABC is similar to triangle XYZ. The scale factor, if I'm going in this order, so from ABC to XYZ, it would be 6 over 3. Whereas, if you look, this order has flipped. If you're going the other way, from XYZ to ABC, you actually have to do 3 over 6, which reduces to 1/2. So just be careful if you're given the order already in terms of a similarity statement, make sure that that's the one that you're using. Don't create your own. All right, so let's incorporate some algebra here. So it says, in the diagram, we have 2 figures that are similar. We have to find X and we have to find Y. So what could be helpful is if you go about this and use some colors. So we only have sides marked. So I know that AC goes with VW. So I'm going to highlight those blue. Then I'm going to go for the second ones. So CD goes with WY. Those match up. Then my third set, I'm going to make red. And then my fourth set, I'm just going to leave. I'll make black. Okay? All right, so you're going to look at all those colors after you color code them, and you're going to say, all right, which 2 match up that do not have any variables with it? Well, if I'm going in this order that they're telling me in terms of similarity, I have to go from the top figure to the bottom figure. So the 9 and the 6, the two green segments match up. So if I reduce 9 over 6, that gets me 3 over 2. That 3 over 2, that is my scale factor that I am going to use to solve my x and my y. So the scale factor is important because that is going to be half of each of your proportions that you're going to use to solve for the missing variables. So if I'm going to solve for x, 3 over 2, now keep in mind I have to start with this top one over the bottom one, would be x over 10. And if I'm solving for y, then 3 over 2 would equal, now I'm doing the black lines, would be 12 over 3y minus 1. And I have my two proportions. So then I cross multiply. 30 equals 2x, so x is 15. On the bottom here, you have to make sure, let me write it out this way, just so that you can see that you're going to have to distribute that 3 to both. So you get 9y minus 3. 9y is 27, and y comes out to being 3. So x is 15 and y is equal to 3. But again, we color-coded it. It makes it a lot easier that way to see what matches up with what. So next one, same idea. So we have JL, first and second, QS. Then we have LM and ST. And then the last set right here. So again, the first thing you ask yourself is which two match up that do not have any variables associated with it, and those are the black lines. So if I'm going in this order from JLM to QST, then I have to do 4 over 2. Well, 4 over 2 reduces to 2 over 1, and that's my scale factor. So that's going to be what I use for half of my proportion to solve for both x and y. If I'm solving for x, these are my green lines. So I have 6x minus 3 over 3. If I'm solving for y, those are my blue lines. So 3y minus 2 over 5. And both these scenarios, be careful, you're going to have to distribute. The first one, not so much because it's multiplied by 1. Actually, both of them, you get lucky. So you get 10 equals 3y minus 2, and now you just solve. So you get 9 equals 6x. X is 9, 6, which reduces to 3 over 2, or 1.5. And here we get y is equal to 4. Final answer for that. Okay? Now, if two polygons are similar, then their perimeters are proportional to the scale factor. So if the sides have a ratio that's in common, the perimeters are going to have the same. So it says we have these two figures that are similar. We're going to find the scale factor, and we're going to find the perimeter. All right, so let's start highlighting. So this one has a bit more segments. So AB goes with PQ. Then I've got BC goes with QR. Then I've got CD, RS. And I've got this guy right down here, and finish it off with my last color, which gets me there. All right, so the nice thing we see when we see this labeled is we've got congruent marks on here. So these are the same, which means this is 8. These are the same, which means this is 4. That's 3 on the bottom, which means that guy's 3 as well. And then 1, 2, 3. And then we got to figure out what those guys are. All right, so first thing you ask yourself is looking here. Do I have two numbers that match up? I do, the red lines. Okay, so if I'm going in this order, that means I have to go top to bottom. So that's 4 over 3.